Hello everyone. Today we will talk about specific functions related to memory management and pointers. Just to recall, in programming, a pointer is a variable that stores the memory address of another variable. We say that pointers play a significant role in memory management. Now let's learn how. Let's talk about memory allocation and functions related to memory allocation. Memory allocation in programming involves reserving a block of memory for storing data. In C, memory allocation can be done statically at compile time or dynamically at runtime. Dynamically using functions like malloc. Malloc stands for memory allocation or memory allocate. It is a function in C that is used to allocate a block of memory on the heap or dynamic memory during program execution. Free is a function in C used to deallocate memory that was previously allocated using malloc or a related function. It releases the memory block back to the system for reuse. Using functions like malloc, alloc, and free gives you access to memory that can make your program more robust and fast. In C, the size of keyword is used to determine the size of a data type or an expression in bytes. When used in conjunction with malloc, the size of keyword plays a crucial role in dynamically allocating memory based on the size of a particular data type. Last but not least, if you want to check memory leaks in your code, you can use a tool called volgrind or valuegrind. All you have to do is to type volgrind before the / followed by the name of your compiled C code, and it will show you memory leaks if there is any. Let's head to VS Code for practical examples. I will open a file, code memory.c. Now I will code a simple example to demonstrate the size of keyword and volgrind. Hash include inside angle brackets standard io.h, then hash include inside angle brackets standard library.h, then end main inside parentheses void, then inside curly braces return 0 semicolon. Now end asterisk x equals to malloc inside parentheses 3 times size of inside parentheses end, then a semicolon, then x bracket 0 equals to 73 semicolon, x bracket 1 equals to 75 semicolon, x bracket 2 equals to 77 semicolon, then free inside parentheses x semicolon. In this code, memory is dynamically allocated using malloc to create an array of 3 integers. The malloc function allocates memory for 3 integers, each of which typically requires size of and bytes of memory. The size of operator returns the size of data type in bytes. Multiplying size of end by 3 ensures that enough memory is allocated for 3 integers in a contiguous block. The allocated memory is then accessed through the pointer x, and values are assigned to the array elements. Finally, The free x statement deallocates the memory previously allocated for the integer array, preventing memory leaks by releasing the memory back to the system for reuse. As you can see, it is a simple example that consists of malloc and free. Now to compile this, make memory, then now we will use volgrind to detect memory leaks. Volgrind /memory. As you can see, it gives info about the memory and says all heap blocks are freed. No leaks possible. Now what if I remove the free block? Now let's recompile and rerun using volgrind, make memory, then volgrind /memory. You can see that it says leak summary, 12 bytes in one block definitely lost. It is because we allocated 3 times the size of int for our pointer variable, but we didn't use free. And since int is 4 bytes, 4 times 3 equals 12 bytes, which is the amount that got leaked. Now let's work on a little different example. Hash include inside angle brackets cs50.h, then hash include inside angle brackets standard library.h, then hash include inside angle brackets stdio.h, then hash include inside angle brackets string.h, and last but not least, hash include inside angle brackets ctype.h. Then int main inside parentheses void open braces close braces, then return 0 semicolon. Then char star input underscore string equals to get underscore string inside parentheses and quotations, enter a string colon, then a semicolon, char star copied underscore string equals to malloc inside parentheses strlen inside parentheses input underscore string +1 colon, then for inside parentheses int I equals to 0 comma len equals to strlen inside parentheses input underscore string semicolon, then I less than len +1 semicolon I plus, then inside curly braces copied underscore string inside brackets I equals to input underscore string inside brackets I semicolon, then f inside parentheses strlen inside parentheses input underscore string greater than 0 inside curly braces copied underscore string bracket 0 equals to 2 upper inside parentheses copied underscore string bracket 0 then a semicolon, then printf inside parentheses and quotations original string colon %s \n comma input string semicolon, printf inside parentheses and quotations copied string colon %s \n comma copied underscore string, then outside parentheses, semicolon, then printf inside parentheses and quotations, memory address of input string, colon, %p \n, comma, input underscore string, then a semicolon. Last but not least, free inside parentheses, copied underscore string, then a semicolon. The user entered string is stored in input underscore string, and memory is dynamically allocated for a new string called copy underscore string to hold a copy of the input string using malloc. The +1 is added to accommodate the null terminator at the end of the string. The program then copies each character from input string to copied string, converts the first character of copied string to uppercase if the input string is not empty, and finally prints both the original input string and the copied string along with the memory address of the input string to the console, as well as freeing the memory, showcasing the process of dynamic memory allocation, string manipulation, and memory address retrieval in C. Now to compile it, gcc memory.c-o memory-l cs50 and then /memory. I will type hello, world. You can see it outputs original string hello, world, copied string hello, world, but the first character is changed to uppercase, and then the memory address of input string. Now to check for memory leaks, valgrind./memory, it asks for a string hello, world, and it says all heap blocks were freed, no leaks possible. This was all for today. Thanks for watching. I hope you learned something. Have a nice time.